Now we can also take a line integral with respect to x or y rather than with respect to the arc length. And really all we need to do is simply replace the delta si with the delta xi and the delta yi when we think in terms of the limits. So the limit as n goes to infinity of the sum I equals 1 to n of f of, using this prior notation, xi star, yi star, delta xi, there's my replacement right there, equals the integral of the curve f of x, y, dx. I'm now taking the integral with respect to x. And likewise, if I take the limit as n goes to infinity of the sum I equals 1 to n f of xi star, yi star, delta yi, now I'm taking it with respect to y, this would be the integral over the curve f of x, y, dy. So this is just really a matter of what it is I'm taking the integral with respect to. Now the same line integrals can be evaluated by simply parameterizing x and y with respect to t. So if I have x is actually a function of t, and then I have y is a function of t. Now this gives me dx dt equals x prime of t. And remember, I had this integral f of x, y, dx. This then implies that dx is actually equal to x prime of t dt. So I can substitute that in for dx, and this will give me the integral over the curve f of xy. But remember, xy are now going to be parameterized function of t, x prime of t dt. Remember, think of this as x of t and y of t. That's what's really down here. And likewise, this integral f of xy with respect to y, if y equals y of t, then dy dt equals y prime of t. That gives me dy equals y prime of t dt. So now I can think of this integral as f of this. I'm going to write it this time with the t in there, just so there's no doubt this has been reparameterized as a function of t. Then y prime of t dt, because this is now my dy. Now this is kind of important to remember because we see these line integrals in so many different forms. It depends on how they come to us. Now line integrals of the form the integral over c of f of xy ds, this is taken with respect to arc length. Whereas the other two up here are taken with respect to x and y. Now, very frequently, line integrals with respect to x and y occur together. And when we have this need, we typically use the notation something to the effect of, depends what book you're using, it tends to be slightly different, but something to the effect of the integral over the curve of some function of x, y, dx plus some function, say q of x, y, dy, which is commonly written as the line integral over the curve of, p of x, y, dx plus q of x, y, dy. And depending on just exactly what it is that we're dealing with, quite often it is easier to reparameterize x and y, because remember this curve is going to be parameterize it in terms of t, and then replace dx with x prime of t dt, and replace dy with y prime of t dt, and then just go ahead and handle the integral. So again, the main purpose behind this discussion is just to present to you a couple different forms that you could be seeing of line integrals and how to interpret those forms.